Hello and welcome everyone. Thank you for joining us today for our webinar titled Building Machine Learning Models at Scale with Sparkling Water. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Elena Boiarskaia is a senior data scientist at H2O.ai. Before I hand it over to Elena, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Without further ado, I'd like to hand it over to Elena.
Hi everyone, this is Elena Boiarskaia. I'm very excited to be here today to talk to you about building machine learning models at scale. Sparkling Water is a very interesting addition to the H2O open source stack. And I'm very excited to present it to you. So I hope to have you walk away today with an understanding of the H2O open source offering, as well as the Sparkling Water architecture and how it can help you run H2O on Spark. So I want to talk to you specifically about building scalable machine learning models with the power of H2O open source and Spark together. So that's Sparkling Water. And we'll talk about how to actually use H2O models inside SparkML pipelines, and we'll review some end-to-end use cases that I have seen that are typically used by our customers. And finally, I definitely want to have you walk away with the understanding of the benefits of using Sparkling Water when it comes to building machine learning models at scale. And so as an H2O product offering, we have quite a few different platforms that help support build machine learning models. Specifically today, I'll be talking about our open source offering. Now, it's enterprise-grade open source offering, so we do offer enterprise support and so on. However, it is open source and it is free to use, and I do encourage you to try it after the webinar, and I'll have some resources for you there. So this is what I'll be focusing on today. Now, H2O open source, for those of you who may not have come across it before, is a machine learning platform that's distributed. So that's both multi-core and multi-node, and it's implemented in high-performance Java, and it's optimized to be really fast for a variety of different machine learning algorithms. The APIs that are available are in Python, R, Scala, and we also have a web UI, which I'll show you. So you can interact with a variety of different, your coding preferences, if you will, and still build models on big data at scale. And the ease of deployment for H2O models is really comes out kind of best in class because of the Mojos. This is something I'll talk you through as well to put these models in production. So deploying these models wherever you build them is really, really easy. So the main features of H2O open source is that we offer supervised and unsupervised learning algorithms. And the cool thing is that I haven't seen in other big data machine learning libraries is that we handle some imputation, we handle categorical variables all inside the algorithm. So for example, one-hot encoding is built into the algorithm, so you don't have to write special code for it. That's pretty cool. And we do have an automated machine learning platform inside H2O-3. So you can have open source AutoML run and decide what's the best model for you, and I'll be showing you that today. So real quick, the architecture of H2O-3. Now, and I am talking to you about H2O-3 so you get a sense of the architecture before we move to Sparkling Water, and you'll see how they're related. H2O-3 is a distributed computing platform. So it does distribute your data across the nodes wherever you're training the models on. So whether it's on your local machine or it's on a Spark cluster, which we'll get to, your data is distributed, your columns are distributed, and you can still interact with it just like, say, a Pandas data frame. So it has the feel of just a simple library of like scikit-learn or some other machine learning libraries you might like. But it is distributed, so all the computations are done in memory, and there's really no limit to the data size. It's only limited by your hardware, right? So it runs on Kubernetes, and specifically today we'll talk about how it runs on Spark. So at a high level, you basically, with H2O open source, you get a variety of ways to interact with it, including your favorite IDE, wherever you like to develop it. I'll be showing you Jupyter today. But you also get the distributed in-memory compute. And again, whether it's running locally or on a cloud, you get these algorithms, and they can be used at any data size, if you will. So here's just a quick list. Of course, you'll get some links to the documentation after the call. But basically, we have some standard supervised learning algorithms. I do want to point out one that is most exciting to most customers, and that's xGboost. You know, this one is, and it's a scalable xGboost, so that's pretty cool. We have recently added Cox proportional hazard model. Again, the automated machine learning option to identify the best supervised learning model for the data that you provide. And then we have some unsupervised learning methods like isolation, for example. That's something that a lot of customers find useful for anomaly detection. So finally, a benefit of H2O is you get this flow interface, which is a guided user interface where you can actually build your models directly on the cloud, on your big data, but using point and click. And so if that's something that's interesting to you, definitely encourage you to play with it. Actually, there's nothing extra needed. Every time you start an H2O cluster, you get this H2O Flow started with it. And finally, for H2O-3, and as well as our other offerings, so anytime we build a model at H2O, we understand how important it is to easily be able to use it and deploy it. So we have this concept called Mojo. Mojo is a model object optimized. So it's basically an object that it can run anywhere, and it contains your entire experiment. It contains everything you need to score new data, and it can be deployed you know, using Java, using Python, C++, cloud or on-prem. It's a really independent object that you can, that's very portable, if you will. Now, the best thing about Mojos, in addition to them being portable and easy to deploy, is that they're super low latency. So this is something that's important for real-time use cases. And I know that Spark offers, you know, streaming options. So this would be very handy if you create a model in H2O using a Mojo. It will offer low latency. That's an important feature to remember. All right, so here's just a kind of a workflow that we'll go through. It's basically once you start an H2O cluster and create a model, you can use this Mojo object anywhere, and I kind of showed this already to you, for deployment in, you know, anywhere you can think of, anywhere that you want to embed some artificial intelligence, some machine learning models. Now, finally getting to Spark. So Spark is a distributed cluster computing framework, and it's really, really good at large-scale data processing. So when you have big data, it's going to be probably one of the best options for you to prepare your big data set, to manipulate it, to create a training set for your machine learning model, right? And this is where H2O comes in. So H2O is specifically a distributed in-memory machine learning platform. So they just kind of go hand in hand since inception. And that was what brings me to Sparkling Water. So when you combine the two, you get Sparkling Water. So you combine Spark and H2O. It is a seamless integration of everything I just talked to you about from the H2O open source stack into Spark. So all it is we use the Spark cluster to initialize an H2O cluster inside it, and then you can run all sorts of H2O models directly on top of a Spark cluster. That's really it. And and in its essence, Sparkling Water is the bridge between Spark and H2O, H2O open source. So data can be easily transferred between Spark and H2O. There's no overhead. They're sharing the cluster. And you can actually embed H2O models directly into SparkML pipelines. So here's an example of that. So here's an example workflow. So typically, you will use Spark for your data munging. You will use it for pre-processing. So you'll load the data in and do your ETL. That's what Spark is great at. Spark has a machine learning library, SparkML, and I think you'll find, and I'll show you some examples where H2O is going to outperform those results, and there's a couple of reasons for that. H2O algorithms don't use approximation, so whenever you scale to really big data on a distributed cluster, we're not going to approximate the results, and so you're actually going to get a more accurate representation, and so your H2O model will be accurate, and you'll get some you'll get some more flexibility, and that's what I'll show you in my demo using code. Having said that, you have your data preprocessing done in Spark, and then you can add a machine learning model using H2O on top of it, where you get a variety of different algorithms, and then you can use Spark to actually deploy the model, and then use it, together inside, say your Spark streaming application, or even, you can definitely use ML Flow, or you can use the Mojo to embed it directly inside a SparkML pipeline. So it's fully compatible with the Spark API. And I'll just talk you through a few cases. So this is one, right? You basically do some data preprocessing in Spark, then jump over to the H2O. They're all going to be on the same cluster, so that'll be a seamless transition. Another option, and I think a lot of customers who move over to using Sparkling Water find this useful, is that you can actually begin some of the data processing using H2O. So say you have an S3 bucket that has some data in it. You bring it into H2O. We have some data munging capabilities to prepare a machine learning model, the training set for a machine learning model. And perhaps there's something that you might want to bring over into Spark. So that's where you can seamlessly bring Spark in along with the ad hoc data transformations from H2O. So you can play around with what makes sense and then do the modeling together again. And finally, I keep talking about streaming. So this would be yet another option is you go ahead and, again, prepare your data in Spark, kind of all in one shot, then create a model using H2O, and then make your prediction on top of Spark data frames. So Sparkling Water essentially gives you this opportunity to use H2O models directly on top of Spark data frames without any need to rewrite your code, etc. And so as promised, so the Sparkling Water benefits that you will find, I think, if you play around with Sparkling Water and H2O-3, is that you actually can use the same code that you've written locally. So if you're writing, say, scikit-learn code and you want to bring it over to Spark, it's going to run on the driver node only because it's not distributed. But if you run H2O-3 code that's local and you bring it over into Spark, it's going to run and it's going to be distributed and it's going to fit on big data. So that's a really huge convenience. Again, model accuracy, this is something I've mentioned. We don't take shortcuts in terms of approximations when we partition the data. And so you will find that the model accuracy of Sparkling Water or H2O-3 models is very high. And the ease of use, handling non-numeric variables like categoricals is built in to the algorithm. There's also going to be missing data handling. So you'll find that if you're writing some Spark applications and you're trying to build a SparkML machine learning model, it's going to be pretty tedious because it'll find all of these kind of inconsistencies and you have to address them all before you actually train the model, and you have to be very specific. These are actually, these conveniences really are built into the algorithms directly. So you can have options too of how to handle categoricals, how to handle missing data. Now we do use excellent, so we do offer excellent open source AutoML, and that's really, it's really a convenience again because you're looking to train a variety of different supervised learning algorithms all at once and see which one works best for you. And it's really just a time saver. It's going to do some grid search for you and it's going to identify, okay, I see that, say, xGboost is the best model for the data you've provided. That's pretty good to know, and then you can start doing something more custom. I love to use it just as a starting point. Finally, you get, not finally, but you get the Flow UI, so again, that guided user interface that you can use directly instead of writing code. You can also look into it as you're running, say, AutoML. You can look into it and see what's happening during the model training. So it's going to be showing you the live flow of what the model training looks like. So it's going to be giving you a lot of information. And I would say a lot more information than you probably expect. So next we have transparency. So I can easily see so the documentation is excellent. I can see my input parameters. I can see my model results. It gives me a lot of metrics, which I really like. So I don't have to necessarily write extra code to evaluate the model. It gives me that information right away. We also have built-in interpretability, so we can expose Shapley values, for example. Shapley values are a very famous way to look at model interpretability and see how each feature contributes to model performance. So Shapley values may be turned on and exposed as you train the model. So in a one-shot, basically, you create the model. You can also give the Shapley values alongside. A variety of different parameters, I'll show you that in a second, that you can tune to see which model does best, and that is all done at scale. H2O models also offer checkpointing, so you can have a warm start essentially, and build, update your model with new data, for example. So that saves you some time and resources, compute resources. And then deployment. So deployment, as I mentioned, is done using a Mojo, and that's actually the concept of this Mojo is the bridge between Spark and H2O. So actually what happens under the hood is that we leverage this Mojo, this model object optimized, to be the bridge between Spark and H2O. So when you have a trained model using H2O open source, it can be easily embedded into Spark. That is what Sparkling Water is. So having said all of this, we have a bunch of resources, and you'll get this deck at the end that I encourage you to test. We have a lot of tutorials online, all free, and we are just rolling out some machine learning foundations courses, and that will include Spark and Sparkling Water. And finally, H2O Aquarium. This is a really neat learning environment where you can actually create a lab, and you have 2 hours, and you can play around with any of our products. And it's kind of, this is our training environment, but you do have access to it. I'll jump over to some code for you. Hopefully this looks okay. All right. So here we go. I've already kind of shown you the architecture piece here. So I am in a Spark cluster, and you can see that, so there's a Spark running now. It's local, but it's a Spark cluster. And then all I'm doing extra is initializing an H2O context. So on top of a Spark cluster, again, I'm building an H2O cluster. And that H2O cluster is optimized specifically for building H2O models, machine learning models. And this is our H2O Flow. So H2O Flow looks like this, and it's our, again, guided user interface. I can import my data. I can see what's going on. I can see which models are being trained. So I kind of started this already. So I have some pre-trained models here and so on. So let me jump back here, and then we'll go over what the code is. So basically, I'm just importing a Spark data frame. So I'm loading a Spark data frame here. So this is all happening using Spark, no H2O yet. And you can do your feature transformers. So if you're familiar with the SparkML library, you might want to use some of the functions there. In this example, we're using SQL transformer just to make it easy and do some date stamp fixes. So this is still PySpark, and just adding some data munging here. And then one thing that SparkML might be useful for is some NLP pre-processing. So it has some nice functions to work with big data to prepare your text for machine learning. And so if that's something that you're already using, or there's some libraries that you like using, this is an example of that, basically. So having all of this prepared, so we've prepared the tokenizer and stop words remover and so on. All of this is going to go into a single pipeline, right? So that's so this is still kind of doing the pre-processing of the text. And finally, what we want to do is create a pipeline, a SparkML pipeline that contains all of these preparation steps for the text text data, and then finally fit an H2O xGboost model on top. And so that is where we will call PySparkling. So this is the Sparkling Water version for Python. And we set up H2O xGboost and add it just at the end of the SparkML pipeline. That's it. So all I've done is create an H2O cluster, run my regular Spark code, and then my H2O model is just, I'm calling, in this case, xGboost, and I'm just adding it to the end of the Spark pipeline, SparkML pipeline. So you can see that the pipeline code looks similar if you've played around with SparkML before. And so reviews_Spark, that's a Spark data frame. And so I'm just fitting this entire pipeline onto a Spark data frame, and that's it. So that works seamlessly, as you can see. So there's really nothing for me to prepare otherwise. Now, what happens under the hood is you get, and you can see this all here, is you get, so the data frame that's uploaded here, you can see what that looks like. You can actually open it and review it, and the models actually started training an AutoML model, so you can review how that xGboost AutoML model looks. And so as you run that code, H2O Flow will collect this information and contain all of this extra information that you might want. For example, a confusion matrix I might want to see, etc. Right? So this gives me quite a lot of information in terms of what's happening during the model training, how it's looking, what the prediction accuracy is, the cross-validation, etc. So that's why I can always refer back to the H2O Flow as I'm running my code. As soon as I invoke an xGboost model from H2O, that will be under the hood converted into H2O land in H2O frame. We'll train an H2O model, create a Mojo, and that's what allows us to. So this is actually what we call a Mojo model, and that's what allows us to seamlessly embed it inside a SparkML pipeline. So it's effectively almost already deployed, if you will. And that's what we're showing here. So basically, it can easily be saved as a SparkML pipeline model, right? So we're just doing the model save over here, and then you can bring it back. And so the deployment piece is really just how you would deploy any Spark model. And in this case, so you're just bringing back loading the pipeline model here. And you don't need to create an H2O context again, because we're using an H2O Mojo, so that model object optimized. So it's that model object that's already kind of standalone, and I don't need an H2O cluster here to score my new data sets. And that's what we have some code here. Now, everything I'm showing you is available in H2O Aquarium, and there's a link to it at the very last page of the deck that I just showed. So you'll have access to this code as well if you start Aquarium. So this is one kind of flow use case I wanted to share with you. And then the other one that I find that customers gravitate towards if they are more like, so it just kind of depends. If you're more heavy into data, ETL, pre-processing, all of that Spark heavy, and you want to use Spark inside your pipeline, then this would be kind of the approach that I just showed. So you have a SparkML pipeline, and so this would be kind of where you embed H2O models directly inside. The other option is to just start directly in H2O. And doing that, and this is a great example here. So I just start an H2O context. This is still on top of the Spark cluster. And then I import the data using H2O. So in this case, I'm directly, so this is an S3 location inside my environment. So I'm bringing it into Spark, onto the Spark cluster, but I'm using H2O. So now loans, in this case, in this example, I'm predicting bad loans. I'm using an H2O frame. So an H2O frame is a distributed data frame. It's similar to a Spark data frame, but it's not the same. And you can switch between Spark data frames and H2O frames inside the Spark cluster if you have the H2O context started. So in this case, I'm just starting directly on an H2O frame, and I'm going to go directly to building H2O models using AutoML. And so setting up an AutoML is pretty quick. I'm just basically giving my target column, and if there's something I need to remove. So basically, don't want this feature used in the model. Otherwise, everything will be used. And that's it. I don't have to do any categorical encoding. I don't have to really specify how to handle my missing values. It's not going to break. It has some built-in handling of those kind of nuances. And here, again, I'm just setting up the H2O AutoML. I'm going to try at most 6 models. Don't use deep learning. We do have a deep learning algorithm. It's a feed-forward neural network. So just for the sake of time, I'm not using it, and I have a clue that xGboost is going to work well. We do offer a stacked ensemble of the best models as well, so that could be turned on and off depending on what you're looking for. And here's the leaderboard. So you run this on the data you've provided, you get a leaderboard. This is all distributed, and you get quite a lot of information. So again, I can examine my information this way. So I'm looking at, okay, this is the best performing model. It's a stacked ensemble. And here are the performance metrics for this model to predict if it's a bad loan or not. And it gives me a lot of information here. So this is I'm just calling the model basically, and it provides a lot of metrics. And at this threshold, you get this value and so on for models. However, if I go to H2O Flow, I get these nice charts as well. So this is the same. They're one-to-one in terms of information. This is just a nice visual of it. So you always get the H2O Flow interface. So I've run this, and it created the Flow interface without me having to ask. Like, that's just what happens along the way, if you will. So it's always there, and you can actually save these flows and share them with your colleagues and go back to them and reuse them and so on. So it's not just reusable code. Obviously, this is straightforward, like you would check it into GitHub, and et cetera, but H2O flows can also be saved. Now, final thing here. So once I create I select a model that I want to use. So this might be my initial learning about the data, right? So I have this really big data set, and I just set this AutoML to run overnight, and I got all of this information, and that might inform what I want to do next. So that would be a typical way for me to work. So I get some information there that way, and then retrain some more models using some customizations, for example. And then you can just jump back into writing your visualization code using, say, matplotlib, etc. Pretty straightforward. And then as far as, so I promised to show you this, there's target encoding. So there's different ways to target encode, and I might want to experiment with those. And so in this case, we're actually adding, you can create a for loop around what you want to test. Now, this is where basically my point is you can get more complicated with these models, and I'm still in H2O open source land, and I'm running it on top of Spark. So I can rewrite this, I can take this code and I can run it locally, and it'll work. I won't have to set up Spark, right? Because H2O is seamlessly connected to Spark, if you will. I can run H2O open source code anywhere, including Spark, and that's what I wanted to show you here. So, and then you can invoke these plots again using your preferred method of visualizations, and keep going with what target encoder to use and so on. So there's quite a lot of experimentation that you can do, but then you can basically treat this as another machine learning library like scikit-learn, but now I'm dealing with really big data, it's distributed, and it's on top of a Spark cluster. So at this point, I'm going to pause for questions, and Patrick, feel free to point them out to me.
Sure. First question we have is, what H2O models support distributed training that utilizes a Spark cluster?
So all of the models, and I have this documentation open here, so all of the models that H2O-3 has are supported on Spark. So all of these are distributed, and so we wouldn't put it out if we didn't create a distributed version of it first.
Great. Next question, does Sparkling Water work on Databricks?
Yes, it does. I actually my previous job, I worked for Databricks, and that's how I know so much about the SparkML library versus the H2O open source library. And those are really the two big players in big data. And so what I'm showing you here in terms of running pipeline and using Spark code, this would be the same exact code on your Databricks cluster. It would be the same exact startup. You just load this, you would just upload PySparkling using PyPy, using their GUI for installing packages, and really the code would be exactly the same. There's really no difference. Mm-hmm.
Great. Next question, what's the difference between xGboost and H2O xGboost?
Oh, that's a great question. So I didn't specify that at the beginning. So we have an xGboost implementation. It is the same xGboost model, but what we do is make it distributed. And so actually a lot of customers are looking for ways to apply xGboost on big data. And the original library is just not optimized for that. It runs in single node. So if you are on a Spark cluster and you just invoke the xGboost library in Python, it's single node. There is a distributed version of xGboost using Scala. I have found it to be a bit buggy. So our xGboost implementation, so this is the H2O xGboost, runs in Python or Scala and is distributed. And we have optimized to be distributed on 100 node clusters. So that is something that sets it apart. Mm-hmm.
Awesome. Next question is, can I use a GPU with Sparkling Water for faster scoring in an EC2? And with what type of EC2 instance is better, GPU, CPU, or memory optimized?
Yeah, that's a great question. So GPU typically works best for xGboost for deep learning. You don't necessarily need an GPU for GLM models, for example. So it really depends what you're doing. If you're running AutoML, you might want to have a GPU instance because you're going to be testing a lot of models in parallel. Again, it's going to include xGboost. That's really what's going to take the resources. Otherwise, CPUs are fine, and that just goes down to the size of your data. Typically, we recommend 4x the size of your data in memory for the size of the cluster. Now, that's assuming that you're not doing anything complicated like, again, xGboost, deep learning, doing some heavy grid search, right? So that's where you'll scale up to 10x to be safe, something like that. Mm-hmm.
Got it. Can I train a model with open source Sparkling Water, derive a Mojo, and use it in production? Or in order to use a Mojo in production, would that require an H2O license?
That's a great question. I'm glad you brought that up. If I wasn't clear, this is all open source and free. So all of the models that you see here, you can train it in Spark using Sparkling Water, derive a Mojo, deploy it. You don't need a license in any capacity. This is completely for you to use. Now we do offer enterprise support for it. So if you are putting it into production and you're making costly decisions on it and stuff like that, we do have enterprise support for open source, but there's absolutely no license needed.
All right. And how can I use H2O in the Google Cloud platform?
Great question. You would just use it like any other library. So if you're on GCP and you have a Jupyter notebook connected to it, you would just load H2O. So you wouldn't need Sparkling Water at that point. Well, yeah, up to you, but you really just would just run something like this. Some code that invokes the library, creates a context, and off you go.
Great. Does H2O Sparkling Water work on Minio?
Well, so Sparkling Water is specifically for Spark clusters. So MinIO, I don't see why not. I feel like that's like for more data storage, I believe. So they could definitely be related.
All right. Can I use any old Spark system that I have access to, or can I create a tiny Spark on top of my Windows 4-core machine?
Yeah, you can. So this is actually the example I'm showing you is local. Just I wanted it to be stable. So basically, you can test any code that you would use on top of Spark locally, and you can create a tiny Spark system. Absolutely.
Awesome. Is Sparkling Water compatible with Visual Studio and GitHub, or maybe Microsoft Azure?
Well, short answer is if you are looking to use the Mojo, then yes. It could be checked into GitHub. It could be added to Visual Studio. Microsoft Azure, if you are on Microsoft Azure Databricks, you can have that support as well, where you run Sparkling Water in that environment. The question is kind of twofold. Can you train models on Microsoft Azure app using Sparkling Water? Absolutely. Once you build those models, can you check them into GitHub using Mojos? Absolutely.
All right. This one is asking, what happens if one of the executors dies while we are training a model? When Spark raises other H2O executors will be ready to use them? I'm not
That's
sure.
a great question, and that is something that definitely bears mentioning. So I've shown you this architecture diagram that we are using a Spark cluster, and we are relying on Spark executors to then support the H2O cluster. And so if an executor dies, you're actually going to lose the H2O cluster. And so the answer to that is twofold. Spark spills to, so here's the difference between the way Spark and H2O handle kind of out-of-memory issues, etc. Spark will spill to disk, and so when an executor comes up, it's going to then be able to resume operation. H2O does not spill to disk. It's a specific design detail that we made this decision because we wanted it to be fast, specifically for training models, right? So an H2O cluster is not like a Spark cluster in that you don't need it running all the time. You just run it for specific training of the machine learning model, right? So in that sense, when you're creating a cluster in Spark, I would in fact, that's a recommendation, you would turn auto-scaling off because we definitely don't want to be scaling executors as we're running an H2O cluster. So that's important. Auto-scaling is off for that specific use case of training a machine learning model. And if we do lose, again, so if you lose an executor, you're going to lose the H2O cluster. On the other hand, I've seen customers do this. This is another option that we support. This specific implementation is using internal backend because I'm just directly using the Spark cluster internally used to run H2O. You can also have an external backend. So we can stand up an H2O cluster externally that does not rely on your potentially, volatile Spark cluster that loses executors, and you can add stability that way if you need this running more of the time, etc. So we offer both external backend, which I didn't mention until now, and then this is the internal backend, which is very, very straightforward and easy to use.
Great. Okay, this one's a three-part question. Well, I don't know if they're all related, but number one, can H2O utilize GPU automatically? And number two, is it possible to share those Jupyter notebooks? And finally, can you explain the difference between AutoML and driverless AI, which is another one of our platforms?
Yeah, so great three questions. Yes to the GPU automatically. Is it possible to share the Jupyter notebooks? Yes, they will be in the links at the end of the presentation. Aquarium contains them, and I urge you to do the tutorials, so there will be a couple of links to that, and you'll be able to find these. And then the third question, we do have, and I'm just going to jump back to my presentation here. We do have, and it's okay, so here's where you'll find, so H2O Aquarium, it's a learning environment that you can use, and it will have the notebooks that I showed you. Also, there's some self-paced tutorials that you might want to check out. And then very soon, we will have a Sparkling Water ML Foundations course that's free. So it's already in progress. I'm specifically saying there will be a Sparkling Water one. Now, to your third question, here is our sort of product suite. And H2O Open Source provides an automated machine learning platform that will test a variety of different algorithms that we offer that's distributed big data. Driverless AI is much more in-depth in terms of building the optimal model for you. It's an enterprise solution that works to actually create automatically feature engineering transformers. It looks for which ones will provide the best value. It creates, it uses actually a genetic algorithm to identify the best machine learning model for your data. So it's a different approach. So this approach, the AutoML approach, uses basically a leaderboard, right, where you test a bunch of different algorithms with different, hyperparameters and see which one performs the best. Driverless AI combines feature engineering, so feature selection, feature engineering, and model tuning, hyperparameter tuning, to identify what works the best for your use case. And it actually supports extensive NLP, and it supports image processing now as of the latest release. And we also have an extensive machine learning interpretability platform where you can really dive deep into the meaning behind the results that you've created using driverless AI. Now, the cool thing about driverless AI, and I'll stop talking, is that you get a Mojo just like here. So the same concept of the model object optimized applies. You get a really lightweight, low latency object after all of that training. So it's going to include the feature engineering transformers and the best model that it's found, as well as Shapley values, as well as like all sorts of things are built into this Mojo, and it's still low latency. So that's the cool thing, is that you can actually take a driverless AI Mojo and then deploy it on top of Spark using a Spark UDF, for example.
Very cool. And that actually leads into this next question. What is the difference between a Mojo and a Pojo?
Mm-hmm. Yeah, this is a good question. Based on the documentation, I can see why that question would come up. We now use Mojo for everything. Pojo is, I guess, an older version. It's if I were to decode it, it would be plain old Java object or something like that. Now, Mojo is kind of the new version of it, where we wrap everything up and it's a binary file that you can deploy anywhere. So that would be, so whenever you use H2O, whether it's open source or driverless AI, that would be the method. Mm-hmm.
Great. Does H2O offer cloud support, like no need for Google or Amazon Cloud?
You would run this on cloud or on-prem. So this would be kind of, we support all clouds in the sense that we will happily run on any cloud or any deployment that you need. So hopefully that makes sense.
Great. And any efforts to become a standard package in Databricks runtime regarding Spark?
So it is, and so a couple of answers to that. In terms of the open source offering, it is supported in ML Flow. So if you search through the ML Flow model flavors, H2O is one of them. So as far as standard, that's that. And you can easily upload H2O PySparkling, or if you're on Scala or whatnot, through their PyPy or Maven. And we have documentation on all of that specific for Databricks. I mean, because just of the way they have their user interface to install packages, it's very easy to do. So you would just have to upload it.
Okay.
Yeah, because the question came.
Yeah, no, I think that's a sufficient answer. Next, is H2O supported on Anaconda?
So if you're running Python through Anaconda, so H2O is just a library. I want you to kind of think of it as a machine learning library first and foremost. Everything I'm telling you about it being distributed, etc., you know, is a very huge added bonus. But the way you would use it, you would think of it just like a machine learning package.
All right. And can you explain a bit more on how to access a Spark cluster in H2O from a Jupyter notebook?
Mm-hmm. So for that, I'm going to assume that you already have a Spark cluster and you have a Jupyter notebook connected to it, because otherwise that would be out of the scope of this presentation. Other than that, you would install the Sparkling Water Sparkling Water library, if you will. And really, so if you are already on Spark, to access H2O from a Jupyter notebook would just involve you writing the following line of code, which is creating an H2O cluster on top of Spark. That's really it. So, I mean, the configurations, we have definitely extensive documentation on it. So it would be documented here. So this is our documentation, and then you're going to go over to Sparkling Water. And there's a bunch of guides depending on which API you're going to use on how to install it. So once that's installed, so you're just going to want to install Sparkling Water on your Spark cluster. So again, I kind of covered that for Databricks, which would just be installing H2O PySparkling using PyPy if you're going to use the Python API, for example. And then that's it. And then you're going to go and create your H2O cluster just like that.
Awesome. All right. Well, I believe that is the last question that we have. So I want to thank you, Elena, for taking the time today and doing a great presentation. I'd like to thank everyone who joined us today as well. The presentation slides and the recording will be made available on our Bright Talk channel later today. And we hope you have a great rest of your day.
Thank you, everybody. It was really great to be here, and thank you for joining.